All right, today we're doing 12.4 area and perimeter of a sector, and this could be something new that you haven't seen before, but it is formula based. So once you look at the diagrams that you're going to work with and have the formulas in front of you, as long as you can, you put the radius and the degrees in the correct place in the formula, which is quite straightforward, and use your calculator properly, then you will be absolutely fine with this, even though it is new to you. All right, so area and perimeter of a sector. So first of all, what's a sector? You might have a minor or a major sector. There's two sections. And if you draw this circle and have it in your books, it's pretty obvious, I would say. So minor means small, major means bigger. So this here is the minor sector, and therefore the one over here, so I'm going to shade this one, and we'll say the shaded one is called a major sector. Okay, now that's just in case a question says what is the major sector, which there aren't very many of, but it's good to know. All right, so you need to write this down. Formula for the area of a sector. So area of a sector is theta divided by 360 multiplied by pi r squared. All right, so you will notice that pi r squared, we know that to be the area of a whole circle. So this is saying take a part of a circle and multiply it by the whole circle, and you'll get the area for just that piece. All right, so let's use it for this one. So this is 20 degrees and this is 4 meters. So from here we can say that theta is 20 degrees and that r is 4. And all we're going to do is put that in with using our calculator. So instead of theta, we know that's 20, so we're going to have 20 divided by 360. And we're going to have multiplied by pi times the radius squared. And we're going to put that all into our calculator and work out what it is. So take a minute, put it into your calculator, and hopefully we get the same answer. I'm doing that the long way, but that's okay. Times pi. All right, I'm hoping you got, if it's 2 decimal places, 140.37 degrees. And I'm just having a look to see. Oh, that's not degrees. Yes, it is. It's area. Sorry. No, it's not degrees. Sorry. We're trying to find the area, so it's meters. So it's going to be meters squared. My apologies. Just be careful if the question doesn't, it'll say a couple of decimal places, or it might say round to the nearest meter in some of the worded questions. So then your answer would be 140 meters squared. So just be careful with that. All right, if you can draw this, please, so that it makes sense to you. All right, let's fill out what we've got. So in this case, we've got, if I was in class, have we got a minor or a major sector? Hopefully you can see that if we did have that part of the circle, this would be the minor and this would be the major. So theta in this case is 216 degrees and our radius is 20. Okay, from here. And I haven't put any, let's put millimeters because I haven't got any in there. All right, using the formula. The formula says theta, so 216 divided by 360 multiplied by pi r squared. So pi times radius is 20, so 20 squared. Now, I'm going to put this in my calculator again and just get one answer. Please, when you're doing this by yourself, you may want to stay in the class or come back to the class if you're not getting the correct if you're not getting the correct answers. Perhaps you are pressing the wrong button on your calculator. So please don't sit there worried about always getting it wrong. If you get a couple in a row, please make sure you come and ask why it is that you're getting what you are. All right, use your calculator and catch up with me in a sec. Okay, I'm hoping you got, let's go 2 decimal places again, 753.98 millimeters squared. Now, I'm just going to double check that, as should you. Yep, I'm happy with that. Hopefully you got that too. Excellent. So that's area, and that's all I'm going to do because they're very similar. And that's, that's what, there's nothing more, there's nothing different to that. So now I'm going to do 2 for the perimeter. But first I want to explain it, and it'll make sense to you when you have a look. So if you have a look at this part, this is kind of like what we just did. So you can notice the similarities. We've got theta over 360 this time plus 2 pi r. And what do we know 2 pi r to be? The circumference of a circle. Okay, so we're going to do this. Okay, I've just made another mistake today. I'm not doing well. This should be a times. Thought that as soon as I saw it. Sorry, everybody, multiply by. So it's similar to the area in that we've got pi over 360, but this time we're multiplying by the perimeter formula. Okay, so it's theta over 360 times 2 pi r, because we know that to be the perimeter of a circle. But you'll have a look here. I've also got in this formula plus 2r. So why are we doing that? Okay, this part here gives us this. So it's saying 2 pi r, which is all the way around. Sorry, we only want a fraction of that. And the fraction that we want is 30 over 360, because that will give us just that. So this part here is just the outside of the sector. So if you look at my diagram, I've coloured in blue what this is. So now you should be able to see, why do I add on 2r? Because I'm going all the way around. I want the perimeter. So there's 1r. I'm still not back to the start. There's another r. So I've got to add on r plus r as well. All right, so let's put all of this in. So we've got radius of 40 and we've got theta of 30 degrees. So I'm going to write it out again just because it's quite a long one and it's great to have it just in front of you. Okay, so we're going to go 2 times radius, which is 40, plus theta is 30 degrees over 360, multiplied by 2 times pi times our radius, which is 40. Now, that's a whopping big question. With my graphics calculator, I can put it all in together and feel very comfortable that I'm going to get the right answer. If you want to write down bits along the way, that's okay, but your green calculator will do that as well. If you write down bits and you've got decimal places, you won't be completely accurate. Okay, so just be careful with that. All right, have a go at putting that in, writing down parts if you want to, and then we'll check it together. All right, let's go for 2 decimal places. So I got 100.94, and have a think, what would it be this time? We're doing perimeter. So it's not going to be squared, it's just going to be, we're saying how long around is that space, like how far around the sector do we go? We go 100.94 millimeters. All right, hopefully you got that. If you didn't, come tell me. Please come tell me. You know I can make mistakes. All right, so next one. Big formula. I'm going to write it out again. Actually, let's say what we've got first. So we've got a radius of 18, and we have a theta of 240. Because you can see this time we actually, what that's saying here, and I'm going to draw all over my page, which you don't need to, is although we can see this tiny bit in here, that's not what we want, because it's given us all of that. All right, it's given us that big part there. Sorry, I said that in the wrong way. So it's given us the 240. So you might think we need that. If you just put 240 in, you're going to get that part. We don't want that. We want this little bit in here. So you have to do a little bit of work first. So what's going to go in here to find that theta? It's going to be 360, because that's how far around in a whole circle we go. Subtract 240. All right, so here we go, 360 minus 240, which is 120 degrees. So in fact, our theta is not 240. Our theta is 360 minus 240. So the theta we want to use is 120 degrees for these questions. All right. You can go ahead and have a go. I'm going to write out the formula. I suggest at least for these examples that you do as well, and possibly in your book as well when you're doing the work. All right, 2 times radius is 18, plus theta now is 120 over 360, multiplied by 2 times pi times, what's the radius? It's 18. All right, so pop that all in your calculator and come back and see if you agree with me. All right, I got 73 point, it'll be 70 if it's 2 decimal places, and centimetres, and no squared because we're doing perimeter. Excellent. Okay, you can look on your lesson plan for which questions to do, or you can have a look here. It's a little bit confusing what I've written, so I'm just explaining. So question 1, I want you to do A, B, D. Question 2, A and C, perimeter and area. So you calculate the perimeter and area for A, perimeter and area for C. Question 3 is 1 multiple choice question. Then 4, A, D and F, perimeter for all of them, area for all of them, and then 5, 6, 8. 5, 6, 8, they don't particularly get very much harder. They're just worded problems, and I think they all have a diagram, so it shouldn't be difficult for you to follow that diagram. All right, terrific. Thanks, guys.